So hi there. In this short video, I'm going to go over most of the things that you need to know for your upcoming test on Java. So we have here the same class that we went over, that we used in the previous video, about transitioning from Scratch to Java. And so I'm just going to go through this class, identify the parts of it, and then sort of spend some time talking about how the different parts can communicate with each other and with other classes, objects of other classes. Because that's, in the end, how classes work. Objects of classes talk to objects of other classes, send information back and forth, and that's how programs accomplish what they need to accomplish. So, first, again, you write public, class, and then whatever the name of your class is. Use a capital letter by convention. You don't have to, but you should. These are your fields, or also called instance variables. Right? Every object that you create of type cat will have its own copies of these variables, whatever variables you define up here in the field area. These should always be private, so that any changes to them are made through mutator methods, and any access to them is through accessor methods of the class. This is to prevent unintended consequences, side effects that could occur if these variables are accessed directly from objects of other classes. In talking to a student once, I said, think of why these are private as kind of like the things in your wallet, right? You don't want anybody messing with the things in your wallet without you knowing about it, right? They're private. So if they need something in your wallet, they need to ask you to get that thing and show it to them, or lend it to them, right? In the same way, you don't want somebody putting something in your wallet. If there's something that should be in your wallet, they should give it to you, and you should put it in your wallet. Okay, so use that idea of a wallet, I suppose purse, I don't know, as just an image in your head when you think about why fields are private. The fields are defined, these two fields are defined as integers. They hold whole numbers, but we could make them any of the primitives that we know about, which are char, double, and Boolean, as well as int, or we could use string. That's the other type you know about. Or since string is just a class, we could make variables of any class types, even classes that we've made. And we've seen this in other programs. So private string, call it word. So this is a variable called string that can hold called word that can hold a string. And you can define as many of these as you want here, right? Next is the constructor. Now, a class can have one or more constructors. This particular one has two integers passed into it via parameters, which are just special variables used to pass information into a method. That's information that the method needs to do its job. In this case, this cat constructor, we're passing in two integers, which are, the first one represents the direction it's heading, and the second one is how much it should turn each time it turns. Right? So the cat, because the cat is going to move, it needs to know this information about how to move. So, in the parameters, which again are just special variables, you specify the type, comma, type, name of variable. That's the pattern, right? You can have as many of these as you want, parameters. Notice on the constructor, there's no return type. It's the only method that doesn't have a return type, and the name of the constructor is always exactly the same as the name of the class. And the function of the constructor is to set when you create an object of the class, it's to set its state to be what you want its state to be when it starts up, right? Okay. And in the constructor, you can call other methods. This is how you call a method of the class that you're in. You just write the name of the method. And if the method needs any parameters, you have to supply those parameters here. But turncat doesn't take any parameters. But let's assume that turncat did take parameters. Let's just say it takes an integer we'll call it size. We call it anything we want. This is the formal parameter. You're describing what the form of the parameter is. But the actual value that will be supplied is supplied when you call the method that requires the parameter. So here, say I wanted size to be 35, right? That's the actual parameter which is stored in size, while the turncat method has control, is running, right? And so that's how the actual parameter goes into the formal parameter and is used while the method that received it is active. Okay? Excellent. Notice there's no return here for the constructor method. You don't write return at the bottom. We'll get to that a little bit more about that in just a second. So here's a method that is a void method, meaning it doesn't return anything. So this method does something, but it doesn't give back any information. We just went over the parameter. It has a while loop in it, which says while the variable cat direction is less than 360, do everything inside the loop body between the two braces, right? And we have some print statements here, mixing up string literals, which are just literally characters between quotation marks, plus some variables, right? And we have an assignment statement here, the equal sign, which is saying take whatever's on the right of the equal sign and store it in the variable on the left. So this takes whatever was in cat direction, adds turn amount to it, and that becomes the new cat direction. Right? Cool. Now, even though this is the void method, we could, if we wanted to, write return here. We don't need to. The void methods, the return statement is actually optional. But an important point, you can have more than one return statement in the method. So if for some reason or other I wanted to return from this point right here, I could write return there. And after it entered the while loop and did the println and set cat direction equal to the new value, it would return, and this method would end. That would be it for that method. As soon as the return statement is executed, the method that the return statement is in is over. It's finished. It no longer has control. Control returns to whatever place the method was called from. So this method would be called from up here, right? So after this method finishes, either from the return statements, or in the case of the void method, by just coming to the end of all the statements in the method, control returns to immediately after whatever called it, right? And Java is basically saying, is there anything else to do in this method? And then there is nothing else, so this method finishes. And since that's all that the constructor does, it just calls turncat. At this point, the object is created, and it's sitting there waiting for us to interact with it, right? To give it a new command. Okay? If, just for argument's sake, we'd had a system out println here, then when return the return was executed here, control returns to immediately after where it got to this method from this turn cat call, and then Java would continue executing the lines, the commands that follow from that point. Okay, so in this case it would just do the system out println. Okay, excellent, good. So let's just write one more method here, and we'll make this a method that returns a string. Right? We could return ints, chars, booleans, doubles, strings, or objects of any class that we're working with. So in this case, we'll return a string. String is a class. So we're going to return an object of the string class, and we'll call this method getWord because when we return things, we're often getting something. So, and we won't pass in anything to this method. Actually, we will. We'll pass in a string. So we'll pass in a string, and we'll call it word. Okay. Now, where's this string coming from? Well, it could be called from some other method within the class. So we could call getWord and then pass in the string. This is the actual parameter. Hello there. Right? And that would be passed in. That actual parameter, that string, would be passed in and stored in Word while the getWord method is active as control. Okay? Or it could be called from another. It could be called from another object of this class or another class. Or it could be called manually via BlueJ by right-clicking on the red object icon and selecting the getWord method, in which case we have to type in the word. And we'll do that in just a second. Okay. And we will say, what we'll do is we'll return word dot. Now what I did is this is a code completion thing, and these are various string methods that BlueJ knows that this is a string, and then it's showing me all the string methods that are available to work with strings. So here's one I want, to uppercase. Right? So the way that works is you put right after the dot, right? Because that's where you would put the method of the class. You just do control space, and it gives you all those. So I'm going to do the uppercase one. What was it? Index of hash code equals. Oh, there's already string methods to uppercase. Just copy it. And just click it. Cool. Nice. Just puts it right in there like that. Word to uppercase. Okay? And do that. So if your method is not a void method, you need to put the return there. It's not optional. Right? And again, you could have more than one return. You could more than one place you could return whatever it is that the method says it's returning. So if it says, if you've declared that you're returning a string, then you've got to return a string. You can't return an int or a double or a boolean. Okay? So let's try this. See here, this is interesting. Java's saying it's impossible for me to ever get to this statement because you have a return right here, right? And that as soon as it hits that return, control returns to leaves this method and returns to whatever the method called this method. So I'd put that there just as an example of to show that you could put return in multiple places. So I'll get rid of that and compile, and that looks good. Okay, so we'll make a new cat we'll just do 1 and 1 here because we're not interested in that right now. And it went through that process of that loop. But now let's call getWord and pass in a word. And we'll pass in tabby. And look what gets returned, uppercase tabby, right? So we'll close that and look at this again. Because we say whatever the word that's passed in is, the toUppercase method turns all the characters in the word to uppercase. Pretty cool, huh? Okay, so what I'm puzzled about is why didn't this get printed? Maybe it did. Maybe it did right at the end of let's see. No, that won't do it. Okay, let's make a new one. Oops, 1 and 1. Oh, I know I didn't do it. That was silly. Okay. Right. Right. Sometimes this happens. You're thinking that returning is printing. It isn't. So getWorld hello there passes in hello there to this. This returns it to here. But what do I do with it? I don't do anything with it, right? So if I said string new word equals that, and then I printed that, again, copy and paste, right? Println new word. So 1, 1. Ah, hello there, all in caps. Was it all in caps? No, it wasn't. It was mostly lowercase, okay? So it worked. Okay. Now a shortcut. Don't have to use this intermediate variable here. This is a local variable. Any variable that's declared inside of a method is a local variable. It only exists as long as that method is active. And then basically Java throws away the variable container until the next time the method is called. So, but what I could have done, since I know that this returns a string, and system.out.println requires a string to be in here, right? It doesn't care how you get the string, it just requires a string to be in there. I could have put this directly in there. This is really cool, right? And get rid of all this. I don't need the local variable. And now when the string gets returned from getWord, it gets returned to here, and then the system.out.println has the string that it wants to print because this returns a string and it prints it out. So just to prove that, let's compile that again. Good. And we'll make a new cat. A1, 1. Hello there. It worked nicely. Okay. So we went over a bunch of stuff here. And none of it terribly complicated. Some of the things you need to, I did want to do one other thing very quickly. I will add it to this method, just the if statement. So you write the word if, then inside parentheses you put a condition that evaluates the true or false. This is called a Boolean expression. Is something that evaluates the true or false. So you could do if word dot equals, right? Because strings cannot be, objects of classes cannot be compared with equals equals, which we can use for primitives, but not for objects of any class, right? We have to use the equals method. It's because objects are complex entities, and and the equals method is different for each class. Somebody else wrote the equals method for the strings class, but what it basically does is it looks at the at the array, the list of letters in each of the string objects to see if they're the same. This is what we want. So if word dot equals, let's say, hello there, actually that's not going to, we'll fix that. There's a little issue here. You may already see it. If word dot equals hello there, then inside of braces, we do the things that we want to occur if that condition is true. So we'll say, oh, I thought I might have had a system.out.println stored. I don't, so I'll go get one quickly. Println, great. Okay, and close the brace. And if I had something that I wanted to help happen if that weren't true, then I could do else system.out.println. Darn, arg. Okay, and close the brace. Right, and I can put as many statements as I want between the braces. You always can. And you don't need the else. The else is optional, right? Now, what's the problem here? Well, if you compile it, you'll see, again, I get that unreachable statement, which means that this return would prevent these lines from ever being run or reached by the compiler, right? So instead of doing return here, I am going to say temp. Well, I can do word again. I can reuse word. I'm going to say word equals word dot to uppercase. So remember, it always does what's on the right of the equal sign first, so it makes all those letters uppercase, and then it stores it back in the word variable. Okay. Now, in doing that, we clobbered the return, which we need. So what we'll do is we'll return down here word. Okay. And this is done after the if-else statement, so it's always done, right? You might wonder what would happen if I put it in, like in here, and I'll leave that for you to explore, okay? Because this video is already getting pretty long. So I'll compile, and remember, exploring is always good with programming. Playing around, it's how you learn. And great, hello there, okay? And why did it print great? Because word was made equal to capital H, capital E, da 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 da, there, okay? By this word to uppercase. Oh, by the way, right, the comparisons you can make for primitives are equals equals, not equals, less than, greater than, and greater than or equals, and less than or equals. Okay, those are you can only do these with primitives. To do things like less than and greater than with objects, you need to use, it's a little bit more complicated, and I'm not going to go into it now, but we will get to it eventually. Okay, so covered a lot here. I hope you're feeling a little bit better about the test. If you do have questions, please let me know. Thanks.